Yeah, hi, good afternoon. So I will be talking about agentic AI for software, briefly coding agents, specifically some experiences that we have achieved in kind of building a coding agent, which is subsequently been transferred into production. So, and specifically what are the issues in trust? That means when really you can trust the agent that you can consider putting them into production. So I'm a professor at the National University of Singapore, and also I'm senior advisor in Sonar, who is the company who acquired our startup. So therefore, it resulted from there. So I'll start from this. So I'll give, this is a LLM agent workshop. So I'll talk of LLM agents for sure, but from the coding perspective, I start from there. So everybody knows about the Hello World program. So this is a poem generated by Claude Sonnet. I asked it to generate some nostalgia about Hello World, but without getting overly emotional. And this is what it produced, that no matter how complex your code becomes, you will always remember the simple joy of Hello World. So actually, the Hello World program was written about 50 years ago. This is more of a stylization by Brian Cunningham. It was written in the B programming language, which is the predecessor of C. In case you thought the predecessor of B is A, that's not true. It's BCPL. I think many of us who are old enough, we know that. So actually, in the B programming language, there was a 4-character limitation. So you would have strings like this. There would be one string for hell because of the 4-character limitation. So since then, of course, things have come a long way. But I feel that in the last 3 years, the changes have been very significant in the domain of coding. So from 1972 to 2022, which is a period of 50 years, I would say that the focus is really on programming at scale. So even though there are verification techniques, for example, software model checking was developed and was subsequently used in production, specifically in Microsoft. People have looked into various showcase examples of operating system verification, compiler verification. The focus is on programming at scale. And only recently, when you are really having this volume of code being automatically generated, I think the trust issue becomes much more important. So really speaking, once we start putting these agents into production, the trust issue will become more and more important. And as was mentioned in several other talks in the past 2 days, that this year is supposed to be the year of LLM agents in particular, 2025. So if we look at the software industry, not just the research, but also the business of software, both the technology and the business of software, since Hello World in the last 50 plus years, there have been only 2 very significant developments. Only 2. Even though there is so much evolution of the field, only 2 very significant developments which affects both the technology and the business of software. So around the development of the internet, around 1995 or so, so around 2000 you had SaaS, software as a service. So this really affects the delivery of the software, the hosting of the software. And this led to many, very, very successful startups. One of them I have mentioned in the slide. This is in the customer relationship management domain. So I think now, 25 years later, we are at a very exciting time because it's not just the hosting of the software, but also the engineering of the software itself we are thinking of changing. And even though a lot of the work we are presenting in this workshop is really on the horizontals, that is the technology. For somebody who is looking into startups and innovation, if they look into verticals, so for example, there could very well be a customer relationship management offering with the agentic technology. And there is a huge potential right now for people who are interested in innovation. And it doesn't require that much software knowledge to kind of make the move on that kind of startup. So just for some inspiration. So a lot of the focus and the progress in the coding agents has been in issue resolution. So I will talk about issue resolution. So actually in my research group, we were looking into issue resolution prior to LLMs, not just with agents. This is how a usual day of a software engineer goes. Very little of the software engineer's day is about coding. A lot of it is about program improvement, improving the program. And then a software engineer might come in the morning and see a host of issues. This could be a bug report that needs a fix, a feature addition, or even efficiency improvement. So prior to LLMs, this is what we were looking into, where you had a buggy program, but you didn't have natural language issues, but you had test cases. This is usually how we would try to tackle the issues, and the issue resolution will produce a fixed program. So how would it proceed to produce the fixed program from the test cases? The answer would be symbolic analysis. And by symbolic, I mean really symbolic. The word symbolic is often used in a loose way to capture any formal analysis, but we were using really symbolic program analysis, as in symbolic execution. Okay? So from the test cases, we would try to infer specifications. This is a generalization of the test executions. This would be followed by a program synthesis step, could be a search step as well, and then subsequently you would suggest the fixes. So let me show this in action, both pre-LLM and post-LLM, using this very trivial example, which everyone here would be familiar with, the triangle example. So it's just trying to take in the three sides of a triangle and telling whether it's a scalene triangle, isosceles triangle, and equilateral triangle. There are many, many bugs in this program. For example, the triangle inequality is not being checked properly. But I'm looking at this bug in particular, where the definition of the isosceles triangle, as you can clearly see, is wrong. So the way you can do issue resolution pre-LLM in this example, in this trivial example, is that you would typically have a test case. This is what a set of test cases that a competent programmer will write. One for an invalid triangle, one for equilateral, three for the two of the three sides, and one for a scalene triangle. And then, given this intent, so this is really the capturing of the intent, because the issue resolution really tries to capture the intent. So given this intent, it would be able to, the symbolic analysis will be automatically generating this fix. And just so that it doesn't look like magic, the way it would do that is that in this particular line, if we know via debugging that this is the line to fix, it would replace it with an unknown function and get properties about that function from the test cases that were written. So this is the kind of properties that it would generate. I don't know anything about f, but for 2, 2, and 3, it should return true. And from this kind of properties, a synthesizer can very easily generate, given the set of operators, generate an expression like this. So prior to LLM, this is the kind of, and agents, this is the kind of intent inference and issue resolution we were looking at, and a lot of it was also being pushed into production at that time. That the intent is given as tests, and we have buggy code. We generate a logical property, and this is really the intent that is manufactured, or rather generalized from the tests, and then you have the improved code. So in other words, you have a high-level intent, and then you get a lower-level intent from there by generalizing. So of course, you need to go beyond tests. So this actually involves a higher-order logic inference, but this is done very, very efficiently within a first-order logic framework by putting the higher-order reasoning at the periphery of the framework. So I will not talk about that today, but we need a mechanism for extracting intent when tests are absent. So this was always clear to us even before the agents, and when agents and LLMs came along, this was an ideal time to look into this, where you now have the intent, the high-level intent, given as natural language, and then instead of a logical property, you generate an explanation. So the agent would generate an explanation. This would be one way of engendering trust, and then you would produce an improved code. So this is the kind of workflow, agentic workflow, we can naturally gravitate from the past work. So between then and now, so apart from the fact that you can see this earlier picture of mine, which looks different, and the current picture, which looks similar to how you look at me now. So between then and now, we really maintain the same workflow. So this is quite interesting to me, at least. We really maintain the same workflow, that there is a high-level intent. There is an intent inference going on, which produces the low-level intent. Then there is a synthesis engine, followed by the patches. The things that changed is, instead of having the high-level intent as tests, we have the issues. Instead of the inference of the lower-level intent being done by symbolic execution, This is how we have designed the LLM agent, where some of that analysis is plugged into the agent. So this is how the analysis is used. Synthesis, of course, is largely being done by LLMs now with some caveats. And now the patches come with additional explanations. So this is, in fact, a bonus. So in the agentic workflow, that we also get these explanations. So given this backdrop, how we kind of came to the issue of agents and issue resolution, this is how we see the issue resolution in coding agents, that we have a software issue, and at the front end, it invokes number of analysis tools. Well, I put the analysis within bracket because initially we had only analysis tools, but gradually we realized that we should also look into other tools like file navigation and so on. So it invokes number of tools, and in the back end there is the LLM, and this works on program representations and files, but it does not really see the entire software project as text. So it's able to leverage the program representation, and from there it's able to generate specifications from the project structure. And I'll describe a bit how that is done. So this is actually our offering. We called it AutoCodeRover because the most key analysis really is the code search that is happening. And so it's really a code rover and then an auto for the automation put on top of it, which we announced, and subsequently we have now put into production. So let me mention a little bit about the salient features and the lessons from there. So first of all, we try to extract implicit intent. So even though there is really we really cannot do symbolic analysis per se as part of the agent, this is not meaningful. We extract implicit intent from the structure of the project. So here is a simple example or a simple, like a schematic, how it is done. Given the issue statement, suppose the issue statement refers to some function A, then the agent has a choice of number of the search APIs to call. Search a function, search a class, search a function in a class, and so on. And then, once it searches that function, it can probably say that, okay, I found one function A in class X, and then you know that, okay, class X is something that you need to pursue furthermore. So in case this is a little bit high level, I just have a slightly more detailed example. But without getting into too much detail, suppose the issue is like this, that we need to understand how the model choice field class handles validation and error messages. Suppose this is what we want to know. Then you would call the search class model choice field, because this is, of course, what you are looking at, and you look inside the signature of that. And now you already have this understanding that you are looking at validation and error messages. So then you can get an understanding like this. This is a more refined understanding that you are getting, that it doesn't have a clean method, so probably it is using some other methods, and from the signatures it can look into this validate and two Python methods maybe, and then it calls the search API search method in class for these two. And this process will go on, and at some point of time, it will look into these two methods, and it decides that this is the method that is responsible, and it should adjust the error message. So this is how the so-called fault localization or the fix localization is going on. This will be followed by a patching step, of course. But you can gain a lot of the intel or the understanding from these steps. So this is the basic design of the agent. Subsequently, we have given that the field of agents moves so fast, subsequently we have made a lot of changes to it. So analysis is embedded inside the agent. Of course, it could invoke tools. But as you can see, the code search could be embedded inside the agent itself. Whatever is being accomplished, even whatever little I showed in the previous slide, this would not be accomplished simply by doing the symbolic analysis of the code. And it would also not be accomplished simply by the natural language analysis of the text. You would really need the project structure for this one. And in this simple example, we only use the project structure for the analysis. We can, of course, do a lot more involved analysis, like maybe this one. This is a subsequent version that we have. We have several versions of this agent, so I'll just go over this one a little bit in details, not too much. We call it spec rover because the specification inference is more explicit. So this takes in a code base, an issue statement, and a regression test suite. So subsequently, it first produces a reproducer test. The regression test suite is optional. So that's why it's in dashed. And then subsequently, with the context retrieval, it will produce both buggy locations and function summaries. Now, function summary usually the way function summaries are deemed is that this is what the function is doing. But that's not the summary we are computing. What we are computing is what the function should have done for the issue to be resolved. So this is really the intent inference or the intended behavior of the function. And then subsequently go back. This goes to the patching agent, which looks into the candidate patches, and there is also a reviewer agent, which reviews the patch as well as the test, and then subsequently tries to do a selection. This is just one particular design. We don't need to stick to this design, but what we have found is having these function summaries is quite useful. So just to give one example, this is like a real issue, which is the natural language description of the intended behavior of the program at a high level. And then in the process of resolving the issues, apart from the patch, the agent will also produce the intended behavior of the individual functions at a low level. So this is the natural language issue. Every single coding agent works with these. This is what I call the high-level intent. In our coding agent, while taking it in, apart from the high-level intent for each of the functions that are deemed relevant, it will also produce a lower-level intent of what it is supposed to do for resolving the issue. We also had, just to share the experience, we also had a number of ups and downs in this innovation cycle. So this is, you will see many of the figures. These are the efficacy numbers in SWE-bench, and then subsequently SWE-bench verified when the SWE-bench verified was introduced. These numbers are lower because subsequently the field has moved quite a bit. Around that time, these were all the numbers the different agents were producing. And actually, our numbers were higher at that time, but we had always had an open version and a closed version. So the policy of SWE-bench verified when it was launched, OpenAI launched it, is that they would take only the open version. So these are some acceptable risks that one has to take when you kind of go down the innovation path from the research. And this is something that was okay with us. One other thing which I would like to mention, and this is quite important, and unfortunately in most of the agentic work, this is not being looked into in the coding agent work, is the user acceptability. That means when the coding agents produce something, whether the result is acceptable, there isn't that much awareness about it. And for this, it's not just enough to look into the true positives that are produced by the agent, but also the false positives and the false negatives. And this is quite important for putting an agent into actual deployment. So the best analogy that I can give is, consider, say, the agent is me, and every time you ask me a question that is an issue, if I try to give an answer, but the answer is just about somewhat there, I don't think you will take me very seriously. But if you ask me a question, and many times I say I don't know, but whenever I answer, the answer is absolutely on the dot, then I think you will take that person more seriously. So when the agents are put in production, at least for coding agents, which is the area that I know, I think that is quite critical. And to my knowledge, most of the works, or maybe none of the works, are looking into this very much. And if there is anybody in the audience looking into this, I would be very happy to talk to them. This would be also one way of evincing and engendering greater amount of trust. This is quite important. So again, you would need to sacrifice some amount of efficacy. You would go down the SWE-bench leaderboard. If your aim is to go up the SWE-bench leaderboard, then it will not be achieved. But you will produce kind of less false positives and less false negatives, and therefore the accuracy, precision, recall, all of these things will improve. This, I think, is quite important for the field to move forward, the signal-to-noise ratio of the agent. This is the mechanism through which we have actually put it in production. So I just added this diagram just to show exactly how it is put in production. It is different from the way the coding agents are being used in research, where the issues are actually written by humans. So the way we are using it, trying to use it in production, is the issues are generated by an analysis tool. This analysis tool is called Sonar Cube from Sonar, which is actually used by currently about 100,000 plus. I think they have much more than that, but definitely more than 100,000 plus enterprises. So there is a huge number of, it's like a customer-facing endeavor. So therefore, if we integrate our agent inside Sonar Cube, along with Sonar Cube, then all of these enterprises which are giving their code to Sonar Cube, if they sign up for the program, then they can also use our agent. So this is the way it is currently being used, just to make it clear. So the way Sonar Cube will work is it will take in, so maybe the user gives a commit or a pull request, and then subsequently you probably build or test, or even otherwise it's a static code analysis. This will be given to Sonar Cube, and it produces a number of warnings for code quality, vulnerability, code smells, all of this, and then it would give it to the user for inspection and fixing. Instead of that, we have now inserted our agent like this. The agent actually takes in not the human written issues, but the Sonar Cube generated issues. And then it would try to commit the fix. Of course, the user can observe and give more feedback. And usually it would be in the terms of accepting or rejecting the patch. So as I mentioned, this is really the year of agents. So fortunately, we got this thing done in the year of agents. And then subsequently, of course, the talk now is exactly how we can enhance more and more trust in this agent as it is put into the production environment. And why that is important is because if we can enhance more trust, then more and more of the enterprises who use the tool Sonar Cube, they will sign up. That's the thing. So that's why the trust is very important. This is just a real incident and actual timing. So we actually had this idea while giving a talk. Somebody asked a question in the talk that, okay, is this the swan song of symbolic analysis? And then we started thinking that what could be the role in the post-LLM area. However, for almost 5 months, we did not start implementing the solution. This was a crucial time that was lost. We started off very simple by saying that, okay, imagine all the program analysis of the world can be invoked autonomously by the agent, and how can we build up an agentic design. We had the public announcement in April 8th, partly also because we were working in stealth. And around that time, if you recall, there was an announcement from Devin, so we decided that we should also go public. And we had the public announcement at this time. And then the acquisition was very quick subsequently because there is kind of interest in this kind of technology, which everybody in the room is very aware. As it turns out, just the next day I was asked for a group photo because this will appear in the various news, including the Forbes Innovation News. And I realized that we don't have any photos at all. So I could not give any photos. But we did go for one dinner after that. That's actually the very first time we went out as a group because we were so busy working. And these are all the team members. Actually, 2 of them, Haifeng and Yun Tong, they are here. So I'll just finish off by mentioning a few other ways in which these kind of coding agents can be used beyond issue resolution, because issue resolution, I think, is just the tip of the iceberg. One way it can be used is really for fixing security vulnerabilities. And for better or for worse, most security vulnerabilities in practice today are found by a technique called fuzzing, which is a biased random search in the domain of inputs. So we have worked in fuzzing. In fact, some of the earliest gray box fuzzers were developed from my group in NUS, and subsequently the fuzz bench was also started by Google once we had all of these developments after a Shonan meeting. So Google has this continuous fuzzing service, which is called as OSS Fuzz. Over time, it has detected over 12,000 bugs in more than 1,000 open source projects. So what we did is we kind of take all those vulnerabilities that are produced and try to work out the agent so that it can produce the fix of those vulnerabilities. So in this case, it would also need the sanitizer bug report and the exploit input. And this is an exercise that we have done and subsequently given these patches that are produced for review by the developers. And we find that this is better than producing fixes using fine-tuned models, because in fact, the fixes that you produce from fine-tuned models, there isn't a whole lot of difference between the scores. We typically use the code blue scores. There isn't a whole lot of difference between the plausible patches, that means which at least pass that one test, and the implausible patches. So the quality of the fixes really does not seem to be, at least experimentally, as good as using an agent subsequent to fuzzing. And in fact, one can look much further. So recently, DARPA had this AI cyber challenge, the AICC, where you would need essentially agentic technology. I think you would need agentic technology, even though it just mentioned use of LLM. You would need agentic technology for at least the pad generation. So one could, in general, if you look at the AICC kind of infrastructure, where you have technology to produce vulnerabilities, that means find vulnerabilities as well as fix them, you would have all of these components like static analysis, patch selection, input generation, this is the fuzzing, crash analysis for the crashes that are produced, and the patch generation. So a lot of these could be done by agents. This is something we have also studied in an upcoming article in Communications of the ACM. In case anybody is interested, you can look inside it. So this is digital infrastructure protection using agents. It's also important to have more and more detailed explanations for greater trust. I think having more detailed explanations is more important. So this is something we have looked into, and I'm happy to talk about it. And finally, let me go towards the conclusion by mentioning that one could develop generalized software engineering agents. So issue resolution is just one activity. One could have many more activities, because a software engineer does more than issue resolution. So if you have to do another task of the software engineer, there would be significant effort in redesigning. So this is the structure and of the agent that we have developed as the latest work. We call it the unified agent because it kind of goes beyond coding and beyond issue resolution. And the way it does is it has an enhanced action space, but the action space is very, very structured. Because, of course, if you invoke a large number of tools, if you invoke a bash tool, if you go to a web browser, you go to Stack Overflow, you have a huge number of possibilities. So here we are restricting the possibilities here, but the capability is enhanced. So the possible steps that the agent can take, that maybe is more limited, but the capability is enhanced. So apart from issue resolution, it can also execute tests, reproduce, retrieve tests, retrieve code, and it can do more and more and more. One particular, two things that we have found very valuable recently, and this could also lead to new directions, is exploring the architecture of the project, even that it is possible to integrate, and also clarifying requirements. So this kind of integrated with some of the other capabilities in issue resolution can really start resembling a real software engineer. We also have some evaluation results on this, but I will probably not go too much into it. So as you can see, apart from SWE verified, we also tried on a number of other benchmarks, subjects, that if you call it, like this SWT, which is for tests, and this repo code, repo test, these are other benchmarks. And generally, we found that this shows reasonably good efficacy across all task types as compared to a specific issue resolution agent like, say, AutoCodeRover, if I just take the open source version, because I'm not reporting any numbers from the closed version here. Okay, so to conclude, in terms of reflection, I think we have spent about 50 years on programming at scale. So as we have this more and more automatically generated code, I think the focus on trust will be quite important. I try to convince that the trust is beyond safety and verification. Verification is one extreme way of getting trust. If the agent can give explanation, that is also trust. If the agent is not the most highly effective, but whenever it gives an answer, it gives it with high confidence and high explanation, that is also trust. If it can produce some tests as evidence, some very interesting tests, and explains why it produces those tests, that is also trust. So verification is a very limited way, I think, or rather one way, a very extreme way of getting trust. May not be limited, but very ambitious way. So I think the issue of trust goes far beyond safety and verification. And this, the human AI boundary in a software team, as we look into the coding agents, if we want to put them in production, where the human AI boundary will be, when exactly you will trust the agent, there could be quite a bit of research that is done there. So let me conclude here while mentioning this two moves in the software industry, each 25 years apart. From in-house development to SaaS, we moved around 2000. And now in 2025, we have moved into agentic AI. We really have moved. I think agentic AI will be put into production. But there are challenges. But it will be put into production in software development. I'm reasonably confident. So most of the work that is happening is on the horizontals, that is on the technology. But there is a huge opportunity to kind of leverage that knowledge of technology to launch very significant startups, if people are interested in that, along the different verticals. We do have this AI for Code Roundtable. It is a meeting of industry, government, and academia that we are organizing at the National University of Singapore. This is on the day before AAAI. So AAAI starts from 20th of January. We have conveniently put it on 19th of January. So if somebody is interested, do let me know. It is an invite-only gathering. And we also have this opinion piece, because this issue of trust will be important for making the research available, really, the exciting research that is being done by the community. Agentic AI software engineers programming with trust, and that will be upcoming in communications of the ACM. But you can scan this QR code and get this article from arXiv. That contains a lot of ways in which you can get trust beyond testing, analysis, and verification. Usually, trust always, we come back to testing, analysis, and verification. That is the validation, but there are many other ways of getting the trust. And we try to access all of those issues. In fact, we distinguish between the technical trust and the human trust in that article. So it's just a short opinion piece, and feel free to look at it and also share your opinions about the opinion piece. Okay? So with that, let me conclude. Thank you very much. And thanks to Ivado for hosting this talk.
Great. OK, so I think we have time. Actually, we have about 5 minutes for questions. So please come to either of the two mics to ask your questions.
Hi. Thanks for a super interesting talk. The building trust is really interesting, and that can, I guess, sometimes be like an iterative process. Like maybe like an agent asks questions initially that it like knows the answer to, but just to show the person that it's like considering them, but maybe like doesn't need to do that later on in time. Do you have any thoughts on kind of like, is like personalization within reach, like where an agent could adapt and like build trust with an individual person? Is that something that's still like a little ways off?
Yeah, that's certainly something that will be happening, I would guess. Means once you start putting in the agents inside the team. But my guess is that would be a later step, because first, currently, for example, this discussion that we had with Sonar, even for them to take the agent and then put it into production, because they also, this is really their bread and butter, right? So the tool, and they are taking the code from all the enterprises. So therefore, if the agent doesn't produce any reasonable fix, then the enterprises that signed up for the program, they would also get worried. So I think we are at a very early stage. In other words, we are at a very good point in terms of the agent capabilities, but we are at a very early stage in terms of trusting the agent. So trusting the agent, first one needs to look into the quality of the fixes. That itself we are not looking into fully. We are very interested in the efficacy. Once we look into the quality, then subsequent thing would be the explanations. Once we look into the explanations, subsequent thing will be that how many false positives, false negatives were there, even in the explanations and so on. Then also there would be the point about the communication that you made. That's very important, because subsequent to that, there would be a communication phase where the human developers in the team would also know what questions to ask the agent. So after all of this would be the personalization within the team. So what you say I would think, if you ask me, I would think it will definitely happen, but probably a few steps down the line. Yeah.
Got it. Thank you.
Thank you.
Great. I might have a question, which is kind of, sorry, I had a timer for the, okay. Which is that to kind of maybe combine your talk with Yvonne's a little bit, one of the reasons that these tools can be built is relying on very large language models, and typically those are harder to run locally, and we depend on like API models. And especially in software development, maybe you don't want to send your code off to someone else's server. So this is another, I guess, aspect of privacy and security of the tools that we are all building, right?
Yeah.
So how does that sort of come into play?
Yeah, this is actually a great point. Again, thanks very much. So you can, so the latest agents that we are looking into, like this unified agent, we can also think about deploying it kind of locally. That means we don't necessarily have to have this API call sent off and try to use the most powerful model. So in other words, the agentic layer itself is getting a bit more capable. So we did experiments on that. I can share about those experiments offline, of course, because those are details and some of the aspects are closed. Some of the aspects of those experiments are closed. But we did do experiments on this, and this is becoming quite feasible. Yeah. But I completely agree with you. Without that, again, it would not be feasible to work on enterprise code. Yeah. Thank you.
Great. Yeah. Any last questions?
Yeah, Parisa. Yeah, that's a great point, because there are many dimensions in here. So first is the efficacy. You can achieve efficacy without quality if you start overfitting to the data set. And one way or another, whether intentionally or unintentionally, because even before SWE-bench, in our program repair community in software engineering, a community that I have been involved in for many, many years, we had data sets. And inevitably, the research papers, because people want to write papers, they would implicitly start overfitting to these data sets. May not be very explicitly. So you can achieve efficacy without quality typically by overfitting to the data sets. That is a definite no-no. But even if you don't do that, there are other kind of subtle issues. For example, is the patch, even if it's a high quality fix, is it really acceptable? That means, is it a good idea to, until the point that we reach the stage where all of the software, the entire software project is being generated completely automatically, maintained completely automatically. There would never be any developer who would ever need to look into anything. The acceptability of the patches, the acceptability of the code, it will also be important. Then whether the agent is really usable. So all of these issues also play some subtle contributions, I would say, towards gaining trust. Yeah, because if the patch is not acceptable at all, this is really not, you are just not going to trust the agent. So all these issues, I think, will remain until the point that you can have the developer completely out of the loop. And why I don't see that as happening, because it is really a very dangerous scenario, not just from the jobs perspective. I know there is a lot of focus on the jobs perspective. Certainly, it's dangerous from the jobs perspective. But if the software is really critical to your enterprise, if you have really removed the entire developer team, so when anything catastrophic happens, you have no expertise left. Nothing left to kind of take care of the improvement of the software. So in the enterprise, at least for the enterprise domain, not like in vibe coding or student project, the enterprise domain, I really don't see that happening at all. So the human AI boundary, defining it in the new way, and defining the new notions of trust will therefore be important, it seems to me. This is still a matter of opinion, yeah.